Well, good morning. This is Mrs. Sharp, or good afternoon if you're a 5th, 6th, 7th hour student here on a lovely Tuesday. And you're missing me, I know, but I have some notes for you. And first, before we do anything else, I want us just to do some practice with what we were talking about yesterday, which was some isotope work. So here we go. I'm going to write up the names of several isotopes. And remember, today we're dealing with atoms, so those are all neutrally charged. And I want you to tell me the number of protons, neutrons, and electrons in each of the following isotopes. So here we go. I'm going to write them up on the screen. You do them in your notes or on a piece of scrap paper or whatever. We'll ask the substitute to pause this for you, and then I'm going to go over the answer. So number 1, I would like for you to write down this isotope. The next one, I'd like for you to write down this isotope. And third, I would like for you to write down this isotope. So I've got N with a 15 and a 7, sodium-23, and fluorine 19. So go ahead and pause this, and I want you to try to find the number of protons, neutrons, and electrons for all three. Okay, let's see how you did. For number 1, the number of protons is the atomic number. That's 7. Since this is an atom, it needs to have 7 electrons as well to be electrically neutral. 7 pluses, 7 minuses gives me 0 overall. Then for my neutrons, I'm going to take my mass number, which is protons and neutrons, which has to add up to 15. So I have 7 protons, so I have to have 8 neutrons to equal my 15. Sodium-23. Now for this one, I would need to look at my periodic table and see that sodium has an atomic number of 11. So that gets my protons and electrons. Now those have to add up to 23, my protons and neutrons have to add up to 23. So 11 plus 12 is going to give me that 23. That's my mass number. And then finally, fluorine 19, similar situation. I'm going to have to look on my periodic table for my atomic number, which is 9. So I have 9 protons, 9 electrons, and then I need 9 plus 10 to make my mass number 19. So those were all atoms. Today we're going to switch gears a little bit and start talking about ions. So let's get into your notes here. What is an ion? Now, I have to admit this. I am a huge dork. I do drive a Saturn Ion. This is a red one. I have a blue one. Most of the time my husband drives it to school, but you know, I thought you'd want to know that. I am a huge dork. But an ion is going to be an atom of an element that has a charge of some kind. So either positive or negative, doesn't matter. But as soon as it has a charge, we don't call it an atom anymore. An atom implies something that's neutral. So as soon as it has a charge, it gets a different name. So you have to be really careful with being specific about your names. If it's an atom, it has a 0 charge, which means its protons and its electrons are equal. If it's an ion, that means its protons and electrons are unequal because we're going to have some sort of charge. Now we're going to learn some fancy pants names for these ions. The first is called a cation. A cation is anything with a positive charge. And the way that I remembered cation is that it has a T in it, which kind of looks like the plus sign there. And there is a cat gymnast, which was not me in a past life. Mr. Muster put that. I was a gymnast. Alright, and negative ions are called anions. So we have cations and anions. Cations being positive with the T looking like a plus sign, and anions being negative. The only thing that can create an ion, and this is so super important that I'm going to give it an extra star here. The only thing that can create an ion is changing the number of electrons. And while you're writing this, I'm just going to do a quick example here for you of, let's do oxygen. Oxygen has an atomic number of 8, and we know that that means if it's an atom, it has 8 protons. And I'm going to represent those 8 protons by 8 positive charges. And it has 8 electrons, which would be in the electron cloud, but I'm just going to show them as being underneath to represent them being 1 for 1. So in an atom, these would all cancel. And my overall charge would be 0. 1 for 1. In an ion, however, if oxygen, let's say, had 2 extra electrons, so we went from this to having not 8 but 10 electrons, 8 protons, and 10 electrons. I would still have oxygen because an atom's identity is based on the number of protons in its nucleus. But now, when those charges cancel, I've got 2 leftover electrons that are not canceled out by a proton because oxygen only has 8 electrons. So this would be oxygen with a -2 charge. So it would be an anion of oxygen. Now we can even do better. We could say oxygen and know how many neutrons it has, so we could say what isotope of oxygen it is. But we haven't changed the mass at all because electrons pretty much have no mass, so that mass number stays the same. What we're changing are the number of electrons. What this statement means is I can't be changing the number of protons because that's going to change the identity of the element. The only thing that I can change that changes the charge and doesn't affect the identity of the element are your electrons. So electrons are going to, changing the number of electrons are going to create ions. So let's do some examples. Here's sodium, and if you look on your periodic table, sodium has an atomic number of 11, and this particular isotope has a mass number of 23. It should look familiar. It's one of our examples from the beginning here. That's an atom if it has 11 protons, and that would mean 12 neutrons to add up to our 23, this mass number, and 11 electrons. So this is an atom because it's neutral. 11 protons, 11 electrons. And the mass number is 11 plus 12. That's where that 23 comes from, just as a reminder. So the same number of protons and electrons mean you have no net charge overall. 11 plus, 11 minus. If you were to set it up, sometimes when I was in high school, I needed to actually see like 11 plus, 11 minus. That would come out to be 0. Let's say, however, I've got a sodium with a +1 charge. And sodium does like to become an ion with a +1 charge sometimes. In fact, in salt, sodium chloride, that sodium is an ion. It's not a sodium atom, it's a sodium ion with a +1 charge. So it's still has 11 protons. That doesn't change because it can't be sodium if it has anything other than 11 protons. So that stays the same. The neutrons stay the same because they're still adding up to 23. But the electrons are now 10 because there's one more proton than electron. So I've got a +1 charge. Or you can think of it like I've still got +11, but now I've only got -10. So 11 minus 10 is a +1. So we would write this like this. So that +1 goes in the upper right-hand corner as a superscript. So this is a cation. Remember, a positive charge looks like my T. So this is a sodium cation with a +1 charge. So we're going to try this with chlorine -1 now. Find your protons, neutrons, and electrons. If I look at the periodic table, chlorine is 17. We need a little bit more information here, so let's say it's chlorine 35. So that means my neutrons have to add up with the protons to make 35, excuse me. So that's 17 plus 18. My electrons now, however, need to be changed. Normally it would be 17, but I've got a -1 charge. So that means I need 18 electrons, because if I have +17 and -18, I've got one more electron gives me a -1 charge. So this would be an anion with a -1 charge. One more electron than proton. Remember, I can't mess with this. That would change the fact that it's chlorine. But if I put one more electron on there, now I've got a surplus of negative charge. If we were to draw out our dots, or excuse me, our plus signs, we'd have 17 of those. We'd have a negative for each one, and they would all cancel, except for we'd have one negative all by itself at the end. So here's a comic for you. I'm hit, I've lost an electron. Are you sure? I'm positive. I love it. So now I want you to try a couple here on your own. And again, we'll ask the substitute to pause this after we get them all on there, and we'll go through them. So let's do 3 again. Let's do, let's do magnesium 25 with a +2. Let's do, let's do zinc. Oh no, let's not do zinc. Let's do, oh shoot. Sorry. Here we go, let me try again. Let's do magnesium 25 with a +2. Let's do sulfur 32 with a -2. And let's do lithium 7 with a +1. Protons, neutrons, and electrons. So pause it and let's see how you did. Okay, here we go. Let's see how you did. For magnesium, our atomic number is 12. We have to have 13 neutrons, so that adds up to 25. And our electrons have to be 2 less than our protons, so 10. So +12 and a -10 is going to give me a +2. For sulfur, atomic number is 16. Had to look that up on the periodic table. Have to add 16 to that to get 32. And with a -2 charge, I need a surplus of electrons, so 2 extra. So I've got +16 and a -18 would give me a -2. And then finally, lithium 7, look that guy up on the periodic table, I get 3. Add 3 to 4 to get 7 for lithium. And then a +1 charge means I'm going to have 1 less electron than proton. So I'm going to have a +3 and a -2 gives me an overall +1. So there we go, guys. Time for you to practice a little bit on your own. I'll be back tomorrow to answer any questions you have, but for now, just do the best you can working through these. Have a wonderful day, and I'll see you tomorrow.